scalability. The traditional LAMP stack model doesn't scale very well or very easily. And by scalable, or by a scalable application, I mean an application that can handle highly variable levels of traffic or unpredictable levels of traffic. So PHP applications more traditionally will scale like this. So you'll add a web server when you need it, which is normally managed by a load balancer, which receives HTTP requests from the internet and will direct each request to a node. Now, each additional server brings with it overhead with things like networking and administration, storage capacity, backup and resource systems. You might have to update some kind of asset management inventory. And because each server has its own disk and its own file system, it runs independently of the other, you might often come up against synchronization issues. So using serverless technologies, this scalability challenge is managed for you. It's managed for the developer. So what that means is if you have a surge in traffic to your application, the underlying services should scale automatically to meet that demand without you having to deploy any additional servers. So what that means is that it allows your applications to transition really quickly from prototype to production. And so in order to understand why now specifically is a good time for PHP developers to have another look at serverless technologies, I think it's useful to have a little look at the timeline of releases of services that has led us up to today. So going back to November of 2014 is when this brand new service called AWS Lambda was first announced. And this is a compute service that runs code in response to events, and it automatically manages the compute resources for you. Then a year later, in July 2015, there was a service launched called API Gateway. So this enabled developers to build secure and scalable APIs really quickly to place in front of a variety of different architectures. Then in November of 2017 was a service called Amazon Aurora Serverless. And this was a new configuration of relational databases that moved it more into a serverless payment model because it allowed you to pay on a second-by-second basis. Then probably the most significant release for this talk was in 2018, where Lambda launched two features on the service. One was called Lambda Layers, and another was called the Custom Runtime API. So the Custom Runtime API is what allows you now to bring any Linux-compatible runtime into Lambda. And Lambda Layers allows you to distribute and share that runtime and any other code across any Lambda function. And we'll talk about how you do that in a moment. Then in September of 2018, there were some significant advancements made for improving Lambda function startup time for functions that are inside a virtual private cloud. And then November of 2019, we launched this service called Rds Proxy, which is a highly available database proxy for relational databases. So this helps to make applications more scalable and more resistant to database failures. So this is the serverless LAMP stack here. You have Lambda, an API gateway replaced the traditional Linux and Apache. And of course, you still have MySQL and PHP. And before I jump into each one of those components, I think it's probably useful to define exactly what I mean when I keep saying this word serverless. So at AWS, serverless is described as something that fulfills all four of these four important tenets. So the first is that there should be no infrastructure to provision or manage. So that means no servers to spin up, nothing to operate, nothing to patch, no physical or virtual container orchestration of any sort. The next tenet is that it should scale automatically by unit of consumption, rather than by scaling of unit of server or unit of compute. There should be a pay-for-value billing model. So another way of putting that is that you don't pay for idle. You only pay for the execution duration rather than by unit of server. And finally, the service must be highly available and secure. So there's no need to architect for availability because that's baked into the service. So the distinction is that when we say serverless, we mean it's the removal of server-related operations. Your code is still running on servers. You just don't ever have to think about that. So that's the important distinction for our customers because it allows customers to focus on building applications and on shipping code rather than managing and scaling the infrastructure that your application sits on. So that brings me to Lambda. And Lambda is a compute service that runs code in response to events, but it doesn't sit in a vacuum. Typically, it forms part of an application that has 2 or 3 different components. So the first component is called the event source, and this is the event that tells your Lambda function to start running code. Okay, and this has this can be a number of different things that does this. You can invoke your Lambda function based on a change in data from a database. You can invoke your Lambda function directly from an API call, or any number of changes in resource state from a variety of different integrated services on AWS Cloud. Then you have the Lambda function itself. So this is a curated execution environment with various languages natively supported. And we'll talk about how you use PHP in Lambda, because it's not actually natively supported. And this is the thing that you upload your code to and that executes and runs your code based on an event invocation. And then the third component is the destination. And this can be whatever your code needs to interact with. It's entirely up to you, and it depends on your business logic and requirements. So at the Lambda function level, there's some interesting things to know about, right? So here you have a screenshot or a code screenshot from 2 different Lambda functions. One is written in Node and one is written in PHP, but they both have all the same components. The first thing to note is something called the function handler. And this is the place where your function starts. It's the first thing that starts running when your Lambda function is invoked. And there's 2 important parameters that are handed to this function handler. The first is the event object. That's the first argument of the handler. And it contains information about the event in a JSON format. So for example, an API request event will hold all the information about the HTTP request object. The second parameter is the context object, and this contains information about the invocation itself and provides methods that allows you to interact back with the runtime and execution environment. And you'll notice above the handler, there's the function's dependencies, and here's where you can put things like configuration options or helper functions and so on. So Lambda, again, is designed to run code on demand in response to events. And if you look a bit closer at the anatomy of a Lambda function, there's several kind of layers. If you go from the outermost layer in, then the first one is the Lambda compute substrate, and that's the underlying compute for all of Lambda. Next, there's the Lambda service itself, which manages the scheduling and the organization of workloads across hundreds of thousands of customers. And both of these layers are completely invisible to the customer. They're managed entirely by AWS. Then the next layer in is what's called the execution environment. This is customer specific and it's AWS account specific. So that's the secure space where your code is run. And inside each execution environment is the language runtime. And then finally, the last layer is your function code that you provide zipped up as a package with any dependencies that are needed. So the A of this serverless LAMP stack stands for Amazon API Gateway. And I'm sure you've heard it said that APIs act as the front door to your backend services. And we have this very comprehensive service at AWS, Amazon API Gateway, which makes it really easy for you to create and maintain and secure your APIs at almost any scale. And these APIs are used to access data and business logic and functionality from your backend applications. And you can build RESTful APIs or WebSocket APIs. It's a really big comprehensive service that has entire presentations dedicated to it, but some kind of key highlights to pull out is that it's great for communicating with microservices. It has built-in protection from DDoS attacks and throttling for your backend application. And you can configure to authenticate and authorize every single request. Excuse me. So the M is MySQL, and that's MySQL running on Amazon Aurora using Amazon Rds Proxy. Aurora is this cloud-native database service that's been, I think it's still the fastest growing service in AWS history. And it creates a database instance inside a virtual private cloud or a VPC, which prevents public access to your database. Then to connect to your Aurora database instance from a Lambda function, that Lambda function must also be configured to access the same VPC. And Aurora provides high performance and scalability for MySQL databases, and the underlying storage can scale to meet up to 64 terabytes, which is approximately 70,000 gigs. And that works really well with this other feature called Amazon Rds Proxy. This is a database proxy that lets you pull and share connections for improved application scaling. So before Rds Proxy was launched in 2019, a common problem that customers experienced was that database was suffering from a form of memory exhaustion. And this was happening when connecting to the RDS database directly from their Lambda functions. It's caused by a surge in database connections or by a large number of connections opening and closing at a really high rate. So if you can imagine hundreds or thousands of Lambda functions opening and closing connections to a single database instance, that was leading to slower queries and limited application scalability. So Rds Proxy was built specifically to solve that problem. It establishes a database connection pool that sits between your application and your relational database, and it reuses connections in that pool. So that protects the database against oversubscription without the memory and CPU overhead of having to open and close a new connection each time. And you get some added security benefits because credentials for the database connection are securely stored in AWS Secrets Manager, and they're accessed via an AWS Identity and Access Management, or IAM role. So that enforces strong authentication requirements for your database. And this is what the kind of token exchange looks like when you want to connect to an Amazon Aurora MySQL database instance from a Lambda function. The Lambda function connects to the database via Rds Proxy, and the database credentials that Rds Proxy uses are held in Secrets Manager and accessed via IAM authentication. Once that token is returned, you can then use that to connect directly to the RDS database. So this is the bulk of what I wanted to talk to you about, which is running PHP on AWS Lambda. So as we know, as keen PHP developers, approximately 80% of the web is still running on PHP because it's still an excellent language for building web applications. And that's unfortunate for AWS because AWS still does not natively support PHP in Lambda. But the good news is it's now very easy to bring your PHP into Lambda. So you can do this not just for PHP, but for any Linux compatible language runtime. And you're able to do this thanks to something called the Runtime API. And once you've built your custom runtime, you can distribute that as something called a Lambda layer. Or until now, very recently, you can now distribute that as a container image too. And we'll talk about both of those in just a moment. Essentially, what the Runtime API is it's a way that codifies the runtime calling conventions and integration points for the Lambda execution environment. And in order to communicate via the Runtime API to the Lambda execution environment, you need to create this special file called a Bootstrap file. And this acts as the kind of bridge between the handler function, which is your Lambda code, and the Lambda execution environment, which is where your code runs. And it uses that Runtime API along with some key important environment variables to form that bridge. And this is what it does. So the Bootstrap is responsible for processing inbound events and headers. It has to initialize the function and invoke it, and it also needs to handle the function response, including any errors that might occur. And then finally, it should also manage the function cleanup too, although that's not a hard requirement. And Lambda runtime sets several environment variables during the initialization. Most of these environment variables provide information about the function or about the runtime. And the keys for these environment variables are reserved, so you can't accidentally overwrite them in your code. And some of them are listed here. So you have an environment variable that holds the host and port of the Runtime API. You have one that holds the name of the handler function, and you have another one that holds the directory of your function code. And this is an example of a very simple Bootstrap file. So this is the Bootstrap file that works, and you can download that and play with this in this from this link in GitHub. And you can see all of those things happening in this file. So here you see that it's processing the inbound event and headers. you see that it initializes the function and invokes it. And you can see that it's using the environment variable to know what the handler function is called. And it also needs to handle the function response and include any errors that occur. So another question that I get often is, how do you manage PHP versions and include different modules and do things like package dependencies? And that's a really valid question. And it's different how you do that. It depends whether you use a Lambda function that you package as a zip file or as a container image. So first we'll talk about if you use a zip file. This is what you have to do. So first you will compile your required version of PHP in a Linux environment. And then you will build your Bootstrap file. And you will zip those two things together into something called runtime.zip, for example. Then you'll use the AWS command line interface to publish that as a Lambda layer. And then you apply that layer to your Lambda function. And you will obviously also upload your function code to your Lambda function too as a separate zip file. This is what that looks like in practice, right? So here I'm compiling my required version of PHP. I'm using PHP version 7.3. I'm including some extensions that I want to use. So this is with MySQLi. I'm packaging this up along with the Bootstrap into something called runtime.zip. I'm using the CLI to publish that to something called a Lambda layer. And here I'm using the Amazon resource name or the address of that Lambda layer to add it to my Lambda function. And I'm doing something similar when I want to create libraries and dependencies. So here I use Composer to install the libraries that I want. This example was showing that I'm using the AWS SDK for PHP because I want to use that in my Lambda function. Then I zip that up into something called vendor.zip, and I use the CLI to publish that as its own layer. And here is a screenshot from the Lambda console where I have two layers. The first layer is my custom Runtime API, the compiled version of PHP with my Bootstrap file. And the second layer is the vendor layer, which holds all of the libraries and sort of functional dependencies. And I can manage these two things separately. Here is an extract from my Lambda function where I'm using that all in my function code. So first I have my use statements to import the classes. I'm importing the PHP SDK for AWS. And here I'm using the SDK to connect to a relational database. So these 3 lines of code is doing this whole token dance that we looked at earlier, all by using the AWS SDK for PHP. So that's building a PHP Lambda function using the zip archive format. Now at reInvent, which is our AWS big customer conference every November, that's the reInvent just gone, we introduced a new way to package and deploy Lambda functions using container images. And this is great if you're already familiar with Docker files and container images in general, or if this is the tooling that your company is already invested in, then this is probably a good option for you guys to look at. It's a little bit different how you do it though. So you create a Docker file, and that Docker file has all your required versions of PHP and all your module dependencies. You still need your same Bootstrap file, and you still need your Lambda function code. And you run a Docker build on all of those things together. You run a Docker tag, a Docker push to the Amazon Elastic Container Registry, and then you apply that to your Lambda function. You apply that image to your Lambda function all at the same time. And this is an extract. I'm sorry, it's a bit small, but it's an extract from a Docker file where I'm doing all those same things, but this time I'm doing it in a single Docker file. So here I'm installing my required version of PHP, version 7.3.6. I'm including all the extensions with the PHP configuration that I'm going to use. Here I'm using Composer. Here I'm moving the Bootstrap into the required directory. I'm installing those libraries and package dependencies that I want to use. And finally, I set the entry point and I tell the image where my function code sits. So that's 2 different ways of building your own custom runtime with PHP, zip archive and container images. Now, if you don't want to start compiling your own versions of PHP, or you're not using Docker and you don't want to be using Docker, you don't actually have to do any of that, because there already exists this fantastic open source custom runtime for Lambda to run PHP. It's called Breath. It has a really active community, and it's already been around, I think, for 3 or 4 years now. And what you do is you go into the Bref documentation, you find your required version of PHP that you want to use, and you grab the ARN or the resource name, and you just apply that directly to your Lambda function. You don't have to do any of the other stuff. And this is probably the sort of most frictionless way to get started. And there actually exists a Bref layer which does something really special. It's called PHP FPM. And this uses the FastCGI process manager, which is traditionally used in applications like Nginx and Apache to manage inbound requests at high load. So Bref's implementation of FPM takes care of lots of different things for you. It makes sure to run each HTTP request as a new process, which is one of the foundation of PHP's share nothing execution model. It also populates all those global variables that you're used to using, like request and post and get. And it provides a mechanism for PHP scripts to return an HTTP response as opposed to the default JSON response. And most PHP frameworks are already built around these FPM features, so that makes it a really good runtime to help you transition from server hosting to serverless hosting, or to serverless in general. So if you want to dive into the PHP FPM custom runtime from Bref, this is essentially what it's doing. You use API Gateway to send a request directly to invoke your Lambda function. The Lambda function environment will start executing the Bootstrap file for the Bref-based runtime. And Bref converts the HTTP request from API Gateway format into the FastCGI format. The Bref Bootstrap then calls PHP FPM through the FastCGI protocol, and PHP FPM will run the PHP handler and return the response. The Bref Bootstrap then converts the FastCGI response to the API Gateway format, and Bref returns a response to API Gateway, which in turn returns the HTTP response to your client or the browser. So to recap, there's actually 3 ways of creating PHP-based Lambda functions, and they all have their different merits, right? One way I think of it is like this. So compiling your own version of PHP in a Linux environment and distributing as layers probably gives you the most control over exactly the footprint of your custom runtime. But using the open source PHP version of Bref is way more convenient because there's much less involved. It's the closest thing that there currently exists to a managed runtime for Lambda for PHP. But one thing that's really interesting to note is that container image functions allow you to upload Lambda functions of up to 10 gig. Okay, so the default or the limit for Lambda, if you don't use a container image, is 250 megabytes, I think. Yeah, I think it is. But with a container image, you can essentially drop in an entire monolith with some, a few configuration changes and create much bigger Lambda functions. So that's something to be aware of. Also, if you're already using Docker, it's a great way to get started with serverless and PHP. So once again, this is the serverless LAMP stack: Lambda, API Gateway, MySQL, and PHP. But I think of it more like this, because this is the direction that your requests are coming in from the internet. You're coming in via API Gateway to Lambda, and PHP is running on top of Lambda, and MySQL is running on Amazon Aurora. It's all happening in the AWS cloud, and your Amazon Aurora database is sitting inside a virtual private cloud, so it's protected from public access. And what you can do, in effect, is to create a kind of catch-all rule that says every request from the internet goes to my API Gateway URL, and then every single request from API Gateway goes to a single Lambda function. And what that means is you're kind of using Lambda as a scalable web host. In effect, you're recreating the sort of similar way of building traditional LAMP stack, where you route everything to a single index.php file. And here you can see 2 different, the old way and the serverless way, or the traditional way and the serverless way of configuring that. So I have an Apache2 config file on the right, which sets my directory of my application, and I have a htaccess file which tells everything to forward to my index.php. So that's 2 different things to manage independently, and I've always had lots of problems with refreshing and updating that. And then on the left here, you can see the serverless way of doing this, where you just set 2 rules API gateway that says route everything to my Lambda function. And you know your Lambda function will scale automatically. So that's the only two services that are involved in your application. One thing to be aware of, though, is the Lambda pricing model. So it charges per request and per duration at the given memory allocation that you set. What that means is that it makes it really efficient at handling requests for dynamic compute or requests where you need to access your database. But it makes it less efficient at serving up static content. So that's where using a service like a content delivery network, such as Cloudfront, would be more efficient. So Cloudfront is a content delivery network which has super large scale. It's global, and it provides a secure and scalable way of delivering content. It does that by caching data across all points all over the globe. And what you can do is you can put that in front of your Amazon API gateway, and you can set a rule in Cloudfront that says any request for a static asset, such as an image or a CSS file or a JavaScript file, route that to an S3 bucket that contains that file, or serve it up from the cache. Anything for dynamic compute, route that via Amazon API gateway to Lambda, and then you have a really efficient usage of serving static content and dynamic compute. And Bref has a very easy way of, with great documentation, on how you can run frameworks like Laravel and Symfony with this exact architecture. So that's well worth a look if you're already building with those frameworks or similar frameworks like CodeIgniter, for example. Another way to use PHP Lambda functions is to create event-driven microservices. And this, I suppose, is the more purist serverless way of building applications with Lambda. So in this instance, you have a front-end application which makes requests to Amazon API Gateway for, I should say as well that your front-end application is static. Anything that requires a dynamic request, for example, anything on /API will go to Amazon API Gateway. Amazon API Gateway can then be configured to route to specific Lambda functions to perform specific tasks. So let's say you have a request to /API/map. That will go to this Lambda function, which is running PHP, which maybe will use Aurora Rds Proxy to set or fetch something to your Amazon Aurora database. But what you can also do is to say anything that's /user, direct that to this Lambda function, which will add something onto Amazon Event Bridge, which is a serverless event bus. Or anything to /search, I want that to be able to add something to a SQS, a queue. Anything to activity, I want to trigger a step functions workflow. And what that means is you're able to reduce the complexity of your one huge Lambda function into multiple very finely scoped Lambda functions. And each Lambda function then has way less code on it, and it's only has the security permissions configured to interact with those services that it needs. So it makes your application less porous and much more secure as a whole. Remember, all of these services are serverless, so they're all scaling automatically in line to handle requests. And this serverless microservice model has been embraced by lots of companies already and their development teams. And one such story is a company called Noptia. And Noptia is a startup founded in 2014, specializes in energy consulting and brokerage. I think it's based in France. And in 2017, they built a SaaS platform for energy bill management, and they deployed this on AWS Lambda functions running PHP using the Bref runtime that we spoke about. So this serverless architecture resulted in a cost reduction of more than 54% within just 3 months. And they have almost 10,000 Lambda function invocations running concurrently, running at the same time. And their platform performance then was greatly improved. They say that their workloads went from 2 hours to under 10 minutes. And what they also saw, interestingly, is an impact on general team happiness, because their smaller development teams never had this dedicated ops or sysadmin person. So using a serverless managed architecture meant the team of developers were able to focus on building and shipping code and not worry about the infrastructure that supports that code. And this is actually a video link where their CTO walks through this architecture in a lot of detail and talks about, the different gains that they had and why they chose Bref. and why they chose Lambda. So that's a really good video to look at. Okay, so how do you get started? My subtle suggestion is to start with a framework. And there's more than one framework that you can use. Normally at this point, I would suggest to use something like the serverless framework or the serverless application model, otherwise known as SAM. But for this particular thing that we're talking about, the serverless LAMP stack, there exists something which might be even more succinct, more useful, and that's the Cloud Development Kit, or the CDK. So the CDK enables you to define cloud resources and infrastructure using the full power of a programming language. So it's not just YAML, it's an actual programming language that you can use to create constructs. And the main power of the CDK really is that it allows you to create these reusable and shareable cloud abstractions, which are called constructs. And these are higher level components that are really important for best practices, and they can be used and stitched together to give you a good starting point to further customize your application. And the CDK construct library for the serverless LAMP stack is an open source abstraction that offers a single high level component for defining all the resources that make up the serverless LAMP stack. So this is something you can deploy, which will deploy the stack that we've been talking about today. And it consists of two constructs, okay? The first is for a Laravel application running on a single Lambda function behind an API gateway URL. And you can connect this to a second construct, which creates a VPC and a Aurora RDS database instance that's running MySQL. And this is how you can do it. So you create directories for AWS CDK and your Laravel project. You create the new Laravel project with Docker. You install Bref and something called Bref Laravel Bridge, which helps you get set up with Laravel very quickly. You install that into your vendor directories. And then you initialize the CDK project. So this one is using TypeScript. And you install the CDK serverless LAMP stack. So I'm using the npm module to do that. And this is what it creates, right? So you can see here I have a file called cdk-stack.ts. That's my TypeScript template that defines all the cloud resources that comprise my serverless LAMP stack. And then in the directory called codebase, that's my out-of-the-box Laravel application, which you'll be familiar with if you've built with Laravel before. And that's where I go in and edit my Laravel application. Now, the CDK stack TypeScript file looks a bit like this. It's very small. And this is an example of this in action, and it's used to deploy a serverless Laravel application directly into a single Lambda function. And this is the actual template file. At the top, I've imported the CDK library and the construct for the serverless LAMP stack. And as part of the constructor, here I provide the Bref runtime that I'm going to use, the layer that I'm going to use, and I put the path to my Laravel code base as the second argument. And then I deploy this using the CDK CLI with the command called CDK deploy. And the output provides me with a new API gateway URL here. And when I click on that, that serves up my Laravel application from Lambda. And here's my out-of-the-box Laravel application that's been served directly from Lambda via API gateway. And that was all created using the CDK construct for the serverless LAMP stack. So what do you do next? You've heard this talk, you want to go and try out more. Perhaps you need some more resources, and there's some great places for you to go and get more information. So the first place I'd recommend is to go to this GitHub repository on the Aws Samples GitHub page. You can get there from s12d.com/lampresources. And this contains code samples, links to a 7-part blog post on the AWS Compute blog. And it has contributions from all sorts of different people using AWS using AWS Lambda with PHP. And it also has a community curated kind of wiki page, which contains links to things like articles and case studies, talks and videos, more coding tools, upcoming events, previous events. And this is curation from people from all over different parts of the world that are using PHP and Lambda. And the third place I'd recommend that you take a look at is a website called serverlessland.com. And this is a website created by the developer advocates at AWS, Serverless. And here you have loads of information about all things serverless. And there actually is a learning path specifically for PHP and Lambda. And that's a great place to get started, where it has all of this information and much more. So to recap, the traditional LAMP stack doesn't scale very well, or at least not very easily. But with serverless technologies, PHP developers can now build scalable web applications without managing infrastructure, without ever needing to do another Apache restart. You can build decoupled microservices for backend applications. You can use mature existing PHP frameworks. And this allows you to build from prototype to production really quickly. You can compile your own custom runtime, either using an open source layer or an image, or you can use the custom runtime for Breath, almost as a kind of managed runtime for Lambda. So you can build serverless applications with PHP, and I urge you as PHP developers, now is a really good time to perhaps take another look at serverless, because it's really starting to show more love for PHP developers now. That's all from me. If you have any questions that you have at any point on your discovery in PHP and serverless, please do reach out to me on Twitter. I'm always happy to have a chat. Again, my name is Benjamin _L_S. Okay, thanks so much for your time, for listening today.